Friends, so welcome back on the series on the RPI. So in this video I will be recording to give you some brief introduction about the GPIOs which are available on the RPI. These GPIOs are essentials to understand because without this you will not be able to configure lot of things like UART, I2C, SPI, all the peripherals we need to communicate through GPIO. So in this video I will give brief introduction about the GPIO, which all functions are needed. So basically I have prepared some slides, and I will also go through the piece Broadcom 2837 chip. So this Broadcom 2837 chip is used in the RPI 3B to developing that board. Okay, so I will show you this data sheet of this 2837 also, and we will see some of the how to set GPIO pin functions, and then what are the functions which are required to basically enable a GPIO pin. Okay, so I have downloaded that 2837 datasheet also. So in datasheet I will show you how we can go through the register space, how we can understand, and based on that only I will explain the functions which are required to basically configure the GPIO pins. Okay, so let's first get some introduction about the GPIO pins. So total 54 GPIO pins are there on BCM 2837. Okay, so I'm not talking about the pins which is coming, physical pins which is coming on the RPI header. I'm talking about the total pins that has been given out of the BCM 2837 chip. Okay, and actually those pins are actually split between two banks. Okay, two banks means just it has been split between two banks, and each pin actually has been given a functionality of either you can use it for SPI communication. SPI you need clock, serial data, and transmit, receive, same as we need in UART. Then I2C also has some pins. Okay, so those pins are basically given to interface any external uh, peripheral to this BCM 2837. Okay, so base address of all the GPIOs will start from this, that 7E to 22 lakh 20,000 7E, and then 20, then all four zeros. Okay, and by default these GPIOs are set to input operation. Okay, and after this we can have this, those pins either can act as an input or output, and either input or output, or internally there is a circuitry. If I will show you here, right? So internally there is circuitry to basically keep this register either high or low. So this is basically to pull up and pull down this register. Okay, and apart from that, this register this pin can be either as an input to the RPI or output from the RPI. So this circuitry is inside the RPI. Okay, so if you set it as an output, then RPI can directly write 1 to set to basically you will get a 3.3 or 5 volt signal from this GPIO. If it is set to low, you'll get volt, 0 volt. Okay, apart from this there are some other functions also. If it is selected to as an input, then if some signaling is given to this GPIO pin, we can detect the signal is low, detect the rising edge, falling edge, and all those things we can detect. And based on those rising edge and falling edge, interrupts can be basically generated. Okay, so total 3 independent GIC pins are going from this GPIOs. Okay, one from each of the bank, and one pin which is common to both the bank. So basically one independent pins has been given for each bank, and one is basically OR of both the banks. Okay, we'll talk about the interrupts and all in some other session, but today we'll talk about GPIOs only. So this is about a brief introduction about this GPIO. We'll see how many GPIO headers are given on the RPI. So on RPI header, you will be seeing total 40 GPIO pins are given. So here numbering is also given from 1, 2, 3, 4. This way you have to count till 40, 1 to 40. Okay. Our purpose will be using these pins to configure UART. So here you can see this GPIO number 14 and 15 can be used as a TXD and RXD. So total 4 signals are needed for the UART: TXD, RXD, ground, and VCC. Okay, ground is here, 5 volt is here. Either you can connect 5 volt, or there is a one more power source that is 3.3 volt in that USB to TTL logic converter. Okay, so only these 4 pins we need. So that's why before giving before starting on the UART drivers, I am trying to give the GPIO session, so that whenever we start on that function, we should be aware how we are setting these GPIO pins. Okay, so we'll go on next slide. So here you can see uh, so total 54 GPIO pins are there, and those GPIO pins can be set to either input, output, or we have total 6 different functions for each of the GPIO pin. So this table is actually given in datasheet also. I will show you. So inside dataset, if you go down in the GPIO section, so here you will see for each of the GPIOs, each of the GPIO can function in any of these 6 uh, functionality can work for this GPIO pin. Okay, and that table has been given, so you can see 0 to 53. Okay, to select whether that GPIO will act as an alternative of 0, 1, 2, 3, they have given a register. That register is basically 3-bit register, 3-bit value. Using this 3-bit value, you can set whether this GPIO can act as an input or output, or if you write it as a 4, then it can work as an this SDA or SCL. Okay, I will show about the GPIO 14 and 15. So this one you can set it using set the alternative 0, then you can use it as a UART 0 to total 2 UARTs are there, I think, in this RPI 3B. If you see total TXD 0, RXD 0, 1, and anywhere else also you see TXD RXD 0 here, TXD RXD 0 here. Okay, so total 4 UARTs are there. Total 4 UARTs are there. As you can see just below that, it has been mentioned UART 0 for transmit data, receive data, and then you have UART 0 clear to send and request to send. Okay, so these are 4 UARTs they have given. 1, 2, 3, 4. Oh, more than 4. But these functions, these are just to clear. Okay, so these we don't have to count it separately. So 1, 2, 3, 4, 1, 2, 3, 4, and 5. Okay, so other pins can also be used. Sorry, my bad. I think only 2 UARTs are there, TXT0 and TXT1. Rest of them, it's just other GPIs you can use instead of that. Okay, so these are total 6 functions which can be selected by using this 3 pins. Okay, so next thing is how do we set this GPIO pin as an either input, output, or any of those 6 functions. So for that we have to basically define the of separate function, that is setup pin function, and after that setting up we have to enable that GPIO pin. So enabling that GPIO pin procedure is also given in this data sheet. If I go here, so here it has been given, same thing I have mentioned here in the PPT also. But to set up the function of a GPIO pin, 2 things we need to find out. First, okay, the input which we need is what is the pin number, and that pin number you want to set to which of the functionality. Okay, 1 out of 6 functionality. So from these 2 values we have to find out the register. Basically we have total 6 registers to set the functionality of a GPIO pin. Those 6 registers I will show you. So those 6 registers are from 0 to 5. Okay, this is the basically total in GPIO module. If you see, total 41 registers they have given, and each register is of 32 bits. Okay, so actually these 6 registers are used to select the functionality of all 56 GPIO pins. Okay, so basically uh, from GPIO pin 0 to GPIO pin 9, this register is used. Okay, so how it is used, I can give a little bit example. Suppose here, right? So total 32 bits are there, right, in one register, and in one register total we need 3 bits to define the functionality. Okay, so 3 into, and in one register space total information about 10 GPIO pins has been given. Okay, so total 30 bits we need out of 32. Okay, that's what I'm trying to show it here. So if you see this register, so here total 32 bits are there. So from bit 0 to bit 2 will be used to set the functionality of GPIO 0, GPIO pin 0. Then from 3 to 5 will be used for GPIO pin 1. Like that it will go from GPIO pin 0 to 9. Similarly it will here from 10 to 19, then 20 to 29, and then for like that it will continue till this GPIO function select 5. Okay, so that is one thing, means you have to find basically for a particular pin which of this register, which of this address you have to modify, and inside this that address you have to find the bit position also. Like suppose for GPIO 1 we will be using this select 0, and but bit position will be GPIO bit position will be bit 3, because 0 to 2 will be used for GPIO pin 0, 3 to 5 will be used for GPIO pin 1. So these two information we need, and based on that we can prepare a basically register value to write inside this function. So using that we can select the setup, we can set up the functionality of that GPIO pin. After that we have to enable that GPIO pin. So we have set the functionality, then we have to enable. So to enable it, basically I will show you the register which we have to modify. So these 3 registers we have to modify to enable that GPIO pin, and how we have to modify, that instruction has been given here. First we have to set it to 0. So let me show you how it has been given. So in the same dataset, if you go down, yeah, so here this is how you can enable that GPIO. That first one is the function setting, and after that we have to enable. So we have to set based on what we want in the GPIO. Either you want to pull that GPIO pin as high, then you have to write 10. If you want to pull it down, you have to write 01. But if you want to disable the pull up and pull down, yes, we have to disable the pull up and pull down. We have to use it as an alternate functionality in case of UART. Okay, so we'll write it to 0, this register. After that we have to wait for 150 cycles, and then again we have to give the clock. So there is a total 3 registers is there. One is enable, then 2 clocks have been given, and each of the bits in this clock 0 and clock 1, total 32 bits, 64 bits are there, right? So 0 to 31 bits is used in clock 0, and 31 to only 53 is used in clock 1. Okay, to give the clock, basically it will give the clock to that GPIO pad, so that to enable that GPIO pin. And after that we have to again wait for 150 cycles, then again remove that control signal and remove the clock. This is the procedure to basically enable a GPIO pin. So when we will start doing this in the function, I will follow the exactly same procedure. Okay, so in this video I just try to show you how which 2 functions we need basically to basically configure a GPIO pin. Okay, after that let me explain a little bit about the register space also here. So based on this how the register space is defined here, we'll define our structure inside C also. Okay, I think this programming, this much information is enough to at least configure any GPIO pin as an input output or any of the alternative functions. Okay, here let me show you the register view. So here you can see, okay, this is just a duplicate of this line. So as I have already told, this registers are used to select the function of a GPIO, and after that you can see there is a reserved space, and after that we are selecting whether that pin will be used as an input or output. So two registers has been given. 0 will be used to set the GPIO pin from 0 to 31, and set 1 will be used from to set the GPIO pin 32 to 53 as an input or output. So you have to write as a 1 if you want. Suppose this value you have written as 2, so you want GPIO pin 1 set as an output. Okay, so this is what you have to write here, and then you have another register space for GPIO pin output clear. If you want output to be, if you want that pin as an output but the value should be 0 on that pin, then you have to write this register, basically the corresponding bit you have to write. Okay, so that mapping I want to basically explain here. 0 to 31 GPIO pins are mapped here, then 32 to 53 are mapped here, again here 0 to 31 is mapped here, and 32 to 53 is mapped here. Same way the pin level also you can be set. So these are basically to read the pin level. Suppose something has been set as an output, so using these two registers you have set the value, then you can read this register to find whether it is set as an output or input. That's why it is written as a read register. Okay, then we have a way to select the event detection. Okay, if any pin is configured as an input and on that pin some signals are coming, going up and down, you can configure that whether you want to detect whenever the signal goes low or whenever you want to detect whenever the signal goes high. So that's why that rising edge detect you have to enable, and then falling edge detect you can enable if you want to detect the signal going low. Okay, so these two signals you can be used to detect. Okay, so once you have detected it, you can basically this is to enable. If you want to detect it, you have to write it 1. If you don't want to enable this, you have to write it as 0. Okay, similarly way we can detect this is for detecting the rising and falling edge. We can detect the high and low level, and we can also detect the asynchronous rising edge, asynchronous falling edge. Okay, so the difference between asynchronous rising and falling is whenever there is a synchronously rising edge, basically that pin, that GPIO pin will be sampled at a system clock rate, and based on that value it will try to find whether, okay, it will sample 3 times. Suppose first time it got 0, then it got 1 1, then it understood that signal has become high, so that way it detects the rising edge. And they have a way to detect asynchronously, means they will detect, means even a small rising pulse. Suppose that pulse is not huge, means it's not of width of 1 clock, even a spurious spike also can be detected using this asynchronous rise and fall. Okay, and I think this one I already have explained. So only these features, and these features can be done through the GPIO. And so in below they have explained about the bit, whatever I explained which bit is used for which GPIO pins. But this is what it's all about, the register space. If we have understood this register space, then we can directly write functions. So next video I will try to write the GPIO function to basically set the functionality of a GPIO pin and enable the GPIO pin. By the time you can go through this register sheet, I think apart from this there is nothing more about GPIO in this. Okay, yeah, that's all I want to say in this video. Okay, thank you.